Hey everyone, Morgan here. So we are going to be looking at plugging some numbers into equilibrium constants today. And this is page 7 of the equilibrium handout for Honors Chem. So here's our reaction. CO2 plus H2 gives us CO and H2O all in the gas phase. We know that the KEQ is going to be the concentration of CO times the concentration of H2O. That'll be divided by the concentration of CO2 times the concentration of H2. Now I have been provided here numeric data for that. I have 0.352 multiplied by 0.352 divided by 0.648 times 0.148. And when I plug all of that into my calculator, I get 1.29. And there are no units included in this. They would have all canceled out this way. So typically, we just don't use units with equilibrium constants. We call them dimensionless. Now, that was for the first trial here. So I called it K1. How about for the second trial? This time I have 0.266 times 0.266. I'm just going to put a squared there. Divided by 0.234, which is multiplied by 0.234. So I'm just going to put a squared there. And when I put that in my calculator, I get 1.29. Of course, these have been rounded off for proper sig figs. For the third trial, I have 0.186 times 0.685 divided by, downstairs I have 0.314, and actually that's going to be squared because it's for both of those. And my calculator says 1.29. Now this is interesting here. All three of these have come out to be the same number. Does that make sense? Well, it does, because these are equilibrium constants. And what is a constant? It's a number that doesn't change. Now, of course, if I change the temperature on this, I'd get a different value. This 900 Celsius. Okay? All right. Now, that doesn't mean every reaction has an equilibrium constant of 1.29. It means this one does. Let's look at another one here. K equals, and upstairs I have HI, which will be quantity squared over I2 times H2. All right. So let's find K number 1. HI 0.0137. And that's going to be squared because of that squared. Over 0.00647 times 0.000593. And when I run that through my calculator, I get 48.9. Now for the next one, 0.0169 quantity squared because of that squared over 0.00384 times 0.00152. And surprise, surprise, it comes out to be 48.9. And then for this last one, 0.0100 quantity squared for 0.00143 times 0.00143. And it comes out once again to be 48.9 because it is an equilibrium constant. All right, that's page 7.